on chemistry. Before we go forward, make sure to like, subscribe, and share. So today's topic is the mole, Avogadro's number, and molar mass. Now, when we hear mole, what do we think of? Now, mole is not an abbreviation for molecule. No, it's not. It's not a short form for molecule. Mole is like a number. Say we have 1 dozen. What comes to our mind when we say 1 dozen? 12. If we say we have 1 dozen of egg, we have 12 eggs. Okay? Likewise, we have 1 mole. 1 mole is equals to a number. That number is 602 hexillion atoms. So 1 mole is equals to 602 hexillion atoms. Now, 602 hexillion atoms is 602 plus 21 zeros. And to punch that into a calculator is too much. We might miss a zero and fail the question. So it is now shortened down to 6.02 times 10 raised to power 23 atoms. So 1 mole is equals to 6.02 times 10 raised to power 23 atoms. Now, as 1 and 2 is called 12, this number is called the Avogadro's number. Okay? So this number is called the Avogadro's number. Likewise, as 1 and 2 is called 12. Okay? So 1 mole equals 6.02 times 10 raised to power 23 atoms, which is the Avogadro's number. Don't confuse it. Don't be scared when you hear 602 hexillion atoms. When you punch this into a calculator, it's easy to solve any question you're given. So, molar mass. What is molar mass? Molar mass is simply the mass in gram of 1 mole. Simple. Molar mass is simply the mass in gram of 1 mole. Say I have a container containing carbon, and I want to know how many carbon atoms are present in that container. What do I do? Hold that thought. So I'm going to give us another question we can relate with. Say I work in an orange plantation, okay, and I receive orders on daily basis, and a customer calls me and be like, I need 8,000 oranges. Now, if I start counting those oranges one by one, 1, 2, I am going to waste time, money, energy, because time is money. And I may have other orders coming in the same day. So counting them one by one is going to take my time. But if I know the mass of 8,000 oranges, I could just weigh them out and I'm done. I get paid and move on to the next order. So say the mass of 8,000 oranges is equal to 457,350 grams. I could just weigh this out on my weighing balance very fast. When it reached this number on the weighing balance, I get my 8,000 oranges. So say I have a container containing sulfur and I want to know how many atoms are present in that sulfur container. And then I know the mass of my sulfur to be 32.07 grams. How do I know that? Well, I looked it up in my periodic table. If you go to your periodic table, you will see something like this. So this is the element, sulfur. This is the symbol of the element. This number here is the molar mass. The molar mass of a substance tells us the how much 1 mole of that element weighs in gram. So the molar mass of sulfur tells us the weight of 1 mole of sulfur in gram. So that's how I got my weight of sulfur. Now, if we go to the periodic table also, we're going to see other elements like carbon, zinc, carbon, zinc, okay? So it's all in the periodic table. So instead of worrying about the molar mass or how to obtain the weight in gram, if you just go to the periodic table, you see it there. So back to our first question where I asked us how to get the number of carbon atom in a container containing carbon. Now we know from the periodic table that 1 mole of carbon is equal to 12.01 gram. Let's say we weigh our container containing this carbon and we get a weight of 55.2 gram. Now the given container of carbon contains a weight of 55.2 gram. So if we want to find how many moles of carbon is in that container, we're going to put this 55.2 gram x. When we cross multiply, we'll be having 12.01 gram x times x equal to 55.2 times 1. So x is equal to we'll be having 4.596 mole. Now we know that 4.596 mole is equal to 55.2 gram. But we want to know the amount of carbon atom present in that container. Now, remember I said that 1 mole contains 602 hexillion atoms, which is equal to 6.02 times 10 raised to the power 23. So if we say 1 mole equals to 6.02 times 10 raised to the power 23. Now, how many atoms of carbon is 4.596 mole going to give us? So when we cross multiply, we'll be having 4.596 multiplied by this. And our final answer should be around 4.6 times, it's going to be around 27.67 times 10 raised to the power 23. We're going to move this here and we'll be having 2.767 times 10 raised to the power 24 carbon atom. So this is the number of carbon atom present in our container. Okay, so I'm going to take examples so that we can get to understand this properly. So our first example, we have to calculate the number of atoms in a substance containing 22 moles. So we're given 22 moles of a substance and we're asked to calculate the number of atoms present. From what I said 1 mole equals 6.02 times 10 raised to the power 23. So how many atoms is present in 2.2 moles? Now when we cross multiply, we're going to be having 1.324 times 10 raised to the power 24. When you punch this in your calculator, this is what you should be getting. Okay, now we're going to take another example. Now say we have 1.3 Okay, say we have 4.6 times 10 raised to power 24 atoms now, and we're asked to calculate the number of moles present in this atom. We're asked to find the moles the other way around now. Now we know that 1 mole equals 6.02 times 10 raised to power 23. Okay? Now we're given 4.6. So you're going to place it on this side. Atoms. And you're asked to calculate how many mole is present. So when you cross multiply, you'll be having x is equals to 4.6 times 10 raised to the power 24 all over 6.02 times 10 raised to the power 23. If you punch this in a calculator, you should be having 0.76411196, which is approximately, when you move this, you'll be having this. So this is now approximately 7.6 moles. Okay, are we having fun? Yeah. So I'm going to give us something that is a little bit extra from this so that we can solve. You can use this method of equating and finding your x, or I can give you a second method, which is the formula method, in case you're not familiar with this. Okay, so if you remember from your knowledge in chemistry, mole is equals to mass over molar mass. Okay, so number of particle is equal to number of mole times the Avogadro's number. Okay, now the number of mole, you can replace this with this. So your number of particle is equal to mass over molar mass times the Avogadro's number. Okay, so I'm going to give us an example, and I'm going to solve using the equating technique and the formula method. Question: say we are asked to calculate the number of magnesium atom, okay, and we're given a sample that contains 1.0 times 10 raised to the power minus 6 gram of magnesium, and we're asked to calculate the number of atoms present. So we're going to use the equation technique. So I have that magnesium from my periodic table has a mass of 24.30 gram, and my Avogadro's number is equal to 6.02 times 10 raised to the power 23. Okay, so I know that 1 mole of magnesium weighs 24.30 gram. Now I'm asked to look for the mole of a sample of magnesium containing 1.0 times 10 raised to the power minus 6 gram. So if I put my 1.0 times 10 raised to the power minus 6 gram here, and I'm looking for the mole, and I cross multiply and divide through, I should be having 4.12 times 10 raised to the power minus 8 mole. Now if I put that back into my equation that says that 1 mole is equal to 6.02 times 10 raised to the power 23, I should be having 1 mole is equal to 6.02 times 10 raised to the power 23. Then 4.12 times 10 raised to the power minus 8 mole should be equal to x. Now if I cross multiply, this times this should be giving me 0.2878 times 10 raised to power 17. Now if I move my decimal place here and approximate this, I should be having 2.878 times 10 raised to power 16. So this is the number of magnesium atom in this sample containing 1.0 times 10 raised to power minus 6 gram. Okay, now I'm going to solve with the formula method so that you guys can understand very well. So any method you choose to solve with is okay. So this is method 1 and this is method 2, which is the formula method. So our formula, number of particle is equal to the mass over molar mass times the Avogadro's number. So our number of particles is equal to the mass that was given. So we're given 1.0 times 10 raised to power minus 6. Our molar mass of magnesium is 24.30 from the periodic table, and our Avogadro's number, which is this, times 6.02 times 10 raised to power 23. When we punch this in our calculator, we're going to be obtaining this, which is our 2.878 times 10 raised to power 16. Okay, so you see, this one does not really take much time, but it's left for you to know which one you want to use. I'm going to take one last question so that you guys become pros in solving Avogadro's number and finding the mole. So for this question, we're going to be using zinc. Say we're asked to find the number of zinc atom in a sample containing 50 grams of zinc. From our periodic table, the molar mass of zinc is 65.38 gram, and our Avogadro's number is 6.02 times 10 raised to power 23. Okay, so if we use our method 1, 1 mole of zinc is equal to 65.38 grams, and we're asked to look for the mole of 50 grams. So 50 grams equals X. When you cross multiply, this is 50 over 65.38, which is going to give us 0.765 mole. Okay, and we know that 1 mole of an atom is equal to 6.02 times 10 raised to the power 23, which is our Avogadro's number. How many atoms are present in 0.765 mole? Now when we cross multiply, we'll be getting 4.6 times 10 raised to the power 23 zinc atoms present. Or we can use our method 2, which is the formula method, which is number of particles equal to mass over molar mass times Avogadro's number. Okay, now our mass here, which is given to us, is 50. So number of particles is equal to 50 over the molar mass of zinc is 65.38, and our Avogadro's number is 6.02 times 10 raised to the power 23. When we punch this in our calculator, we'll be having 4.6 times 10 raised to power 23 zinc atoms. So now you know how to obtain your number of moles when you're given the number of atoms present, and you know how to calculate the number of atoms present in a sample when you're given the number of moles of that sample. Okay, we've come to the end of this class. Give me a thumbs up if you want more lessons on chemistry. Thank you very much. I remain Ezugwu Emelda. Goodbye.